Welcome back. This is Nick Agram. In this video, I will be discussing Theorem 3. It says, the angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circle on the same side of the chord as the center. So if, as you can see here, we have, this is V is the subtended arc angle, and U is the central angle. They have the same arc, as you can see. AB is the arc, so AB is the arc of angle V, and also AB is the arc of angle U, and V is a subtended arc angle, and U is the center angle. So if that's the case, it says here that U is equal to 2V according to the theorem. And then let's prove that. I have here, I will prove that y is equal to 2x according to here. And y, according to theorem number 3, it says here that the arc AB is the arc of y, angle y, the central angle y, and the same is true with AB. The arc AB is also the arc of the subtended angle C, x. According to theorem number 3, y is equal to 2x. It is double. Y is double. Let's see. If I'm going to put this now, let's say this is A. Then we see that y plus A is equal to 180 degrees. Why? It is a straight angle. And then we have the sum of the triangle. Angles of the triangle is always 180. Then we have A plus X plus zeta is also equal to 180. Sum of the triangles angles. Then equating both are 180. Y plus A is equal to A plus X plus zeta. Then subtracting both sides of the equation by A, and this is 0, that is also 0. As you can see now, y is equal to x plus zeta. But this now, this is a radius. This is also a radius. That means we have an isosceles triangle. Isosceles triangle, the angle on the base is always equal. So that means x is equal to zeta. That means y is equal to x plus x. Then y is equal to 2x. That's a proof. We call this a very simple proof. But there are sometimes, as you can see here, it is through the center, it is a diameter. How about if it's not a diameter, as you can see here? What we can see here now, we still have y is equal to 2x. Why? Because they have the same arc. AB is their arc. But now it is a little bit different. We have we don't have the same as what we have here. It is not a diameter. This is now not a diameter. But we can still do that. We can draw a line through the diameter. So this one, we can call that, we'll get another color. We call this y sub 1, y sub 2. And then this is one x sub 1 and x sub 2. So we have to declare that we have x sub 1 plus x sub 2 is equal to x. Y sub 1 plus y sub 2 is equal to y, according to what we did. And then, now you can see this is now a diameter. The first proof that we have done is a diameter. So according to that, we have y sub 1 is equal to 2x sub 1. And we have y sub 2 is equal to 2x sub 2. So we have y sub 1 plus y sub 2 is equal to 2x sub 1 plus 2x sub 2. And then y sub 1 plus y sub 2, we declare that it is y. And then we have 2 times x sub 1 plus x sub 2, common factor. And x sub 1 plus x sub 2 is equal to x. So we have y is equal to 2x. We have proven that y is equal to 2x. Even we cannot find a diameter. But you can see here, the x is over the y. How about if it's not the case, as this case? It is not over the y. X is not here. We can still use the first proof that we have done by drawing once again a diameter. So as you can see now, we have here this part. We can call that x sub 1 and this part x sub 2. So such that x is equal to x sub 2 minus x sub 1. Sorry, yeah, the whole thing is x sub 2. And we have y, this one now, is y sub 1 and the whole is y sub 2. We have y is equal to y sub 2 minus y sub 1. According to what we have learned, y sub 1 is equal to 2x sub 1 and y sub 2 is equal to 2x sub 2. And we have y sub 2 minus y sub 1 is equal to 2x sub 2 minus 2x sub 1. And y sub 2 minus y sub 1, we have declared that it is equal to y is equal to 2 times x sub 2 minus x sub 1. And we have 2x. Then we have proven also. So it doesn't matter if they are above each other, as long as they have the same arc. That's the most important. As long as they have the same arc. Doesn't matter if it looks like this or it looks like this, or it looks like this. They have this theorem applies. Y is equal to 2x. Here are some examples. We're going to solve for A, B, C, D, E, F, G. For A, according to the theorem, A is always the half of the central angle. So we have 98 degrees divided by 2. That is 49 degrees. For B, it is always, the central angle is always double the subtended angle. So we have 48 multiplied by 2. 48 degrees. Then we have 96 degrees. They have the same arc. So we have C is half the central angle. So we have 90 degrees divided by 2. That is 45 degrees. Let's see the other. This is a little bit confusing here because some of my students always think that this is the central angle. No, it is not. Why? Because this is your arc right now. That is your arc. If I call this A, this is B. That is your arc. And that means the central angle is from A to B. It follows the same. So we have for D now is double the 117 degrees. That means we have 234 degrees. For E is always 1/2 the central angle, and we have 180 degrees divided by 2, then we have 90 degrees. For F is equal to, our central angle is 48 degrees, and F, it should be, the subtended angle should be half of that. So 48 degrees divided by 2. Then we have 20 and 24 degrees. I hope you learned something about this theorem number 3. And in my next video, I will be giving you more examples, a little different example, and a little more difficult example. So see you around.